folks. It's a glorious Sunday afternoon in March. We have been really lucky this winter that usually the gloomy months of February and March have actually been quite sunny. So, gorgeous day out there. I'm going to get out and go for my power walk and crawl back home. I wanted to spend some time today creating some illustrations of how the AstraZeneca vaccine works. This is a viral vector vaccine, which is very different from the messenger RNA vaccine. We all know about the messenger RNA vaccines. Many people, 800,000 or so, have already received the messenger RNA vaccine. This is the next vaccine that's been approved by Health Canada and is now in the country, and some folks have received this vaccine too. We have quite a few of this vaccine to use up by April 2nd, and so many of you may be offered this vaccine earlier than you would have been offered a vaccine otherwise. So we'll see how that goes. And then there's Johnson & Johnson, which is similar. It is also a viral vector vaccine. I'll post about that one later. The viral vector vaccine technology is, we've known it for much longer. It's been used to make the measles vaccine, the Ebola vaccine, and different pox vaccines. So we know this technology. It's a technology that uses something called recombinant DNA technology. This is very complex stuff, so I'm just going to simplify. Okay, so we all know what the coronavirus looks like. Here it is up here, the COVID-19 virus, with its genetic material, which is RNA inside the cell or inside the virus, and its spike proteins, which we all know about. And this spike protein, because it is so characteristic of the COVID-19 virus, is very attractive to vaccine makers because it can be easily isolated or easily produced, relatively, and then used to coax your immune system to make antibodies to the COVID-19 virus, which is what this vaccine does. So essentially, they take the spike protein genetic material, an actual piece of the genetic material that codes for the production of the spike proteins on the surface of the cell. They then use this complicated technique to make that protein or that genetic material into DNA, and then that DNA is inserted into a virus, thus the viral vector technology. And the virus they use is a modified chimpanzee adenovirus. This is a virus that will infect chimpanzees, but it cannot infect humans. So if you are exposed to this virus, you won't become ill. And if this virus is given to you through a vaccine, it will not cause illness. So they now have taken this modified chimpanzee adenovirus or cold virus and filled that up with the genetic material, this time DNA, that codes for the production of the spike protein on the coronavirus. So that's what we want. We want to replicate the spike protein in our own body so that it triggers our immune system to create immunity against COVID-19. So they take this modified chimpanzee adenovirus, now filled with DNA for coding for the spike protein for the coronavirus spike protein, and it's made into a vaccine. This vaccine is given to you. It is a two-shotter. It can be given 21 to 48 days apart, so there is a length of time that we can postpone before giving a second dose, but it is 2 doses. When the vaccine is administered, these chimpanzee viruses that have the genetic material that codes for just the spike protein then enter. Here's our human cell, here's the cell membrane, here's the nucleus of the cell, which is responsible for all the functions of the cell. And the cell does what it's supposed to do in your body based on proteins that the nucleus produces. And these proteins go to the surface of the cell and instruct the cell as to what it has to do. Again, if it's a liver cell, it does its liver thing. If it's a lung cell, it does its lung thing. If it's a muscle cell, it does the muscle thing. But all of that comes from the genetic material in the cell and messages that go to the surface of the cell through messenger RNA that code for the production of proteins that then do what they're supposed to do. So now we have this adenovirus that's filled with the spike protein genetic material. It enters into the nucleus of the cell. The nucleus starts to produce, yes, messenger RNA for the spike protein. That then starts to be replicated in large amounts. Proteins are created, spike proteins, that go to the surface of your cell. Here's the human cell again. All of our cells are made, they do their thing, and then they die. They're created, then they die. They're created, and then they die. So there's a constant life cycle to our cells. And so they're constantly dying. When this cell that's covered in spike proteins that look very similar to the coronavirus spike proteins dies, here's an image of it dying down here, the spike proteins are then released into the bloodstream. Once the spike proteins are released into the bloodstream, they're seen as foreign. And your body will look at that foreign object and say, that's not supposed to be here. We're back to what the messenger RNA vaccines do. That's not supposed to be here. It triggers something in your immune system, a cell called a helper T cell. That helper T cell takes a look at the spike protein and says, wait a minute, that's abnormal. And it presents the information from the spike protein to a B cell. And the B cell, produces antibodies. And it produces antibodies that go after the spike protein, these red dots on the coronavirus. So if you are exposed to the coronavirus, they circulate in your system. The B cells have made antibodies. The antibodies attacked the COVID-19 virus, and you do not get infection. That's how this vaccine works. Pretty simple. We've learned this technology before, or we learned how vaccines work before. So we're all becoming educated about vaccines and how they work. Um, the one thing about this vaccine is that it is very low risk. You can get pain and swelling at the site of the injection, muscle aches and pains. Your lymph nodes might be swollen. You might be fatigued and have a low-grade fever, but very, very few serious complications so far in its real-world use. And again, it may not be as efficacious or effective as the messenger RNA vaccines, which are out there being 93% effective. This one's about 63 to 67% effective, but it is almost 100% effective at preventing serious disease and hospitalizations. So this vaccine may be used more in the scenario of young people who are at low risk of getting serious illness and needing hospitalization as a result of COVID-19 to protect them, while reserving the more effective messenger RNA vaccines for people over 65 or with chronic health conditions who we want a big, powerful vaccine right up front that prevents them from getting the illness at all. There's a beautiful place for this vaccine in our toolbox. We will start to be administering this vaccine very soon. Yes, in Canada, it will be for people under the age of 65 and without chronic illnesses, but it is effective in people over 65. So there you have it, in less than 8 minutes. An explanation of the AstraZeneca COVID-19 vaccine. I need a new whiteboard. Hilarious today as I was making this, I dumped a cup of coffee all over top of it. So I have a stained whiteboard. I'm going to buy a new one. Someone told me to get camera equipment to make a better video. Nah, I'm not going to do that. This is good. You guys understand it. Ask me questions on my next post. Okay, take care, everybody. Enjoy the day.